Hello dear students. In this lecture we will discuss the problem which is called longest increasing subsequence, and we will solve this problem using the dynamic programming approach. So what is the problem statement? This longest increasing subsequence problem, which is also known as longest ascending subsequence problem, is such that you are given an array of n elements and you have to find the length of the longest subsequence such that all the elements of the subsequence are sorted in strictly increasing order. So let us take an example to understand this statement. So this is the sequence or the array which is given to you, and it has n number of elements where n is a 9 here. Okay, and from this array we have to find the longest subsequence such that that subsequence has all the elements sorted in increasing order. Okay, so if we pick 10, then 22, then this is sorted. Okay, but if we pick 9, then now this is not sorted, so we cannot pick 9. So we skip 9. Then let us take 33. It is increasing. Okay, then next consider 21, but it cannot be taken because it is smaller than 33. Then 50 can be picked, 41 cannot be picked, 60 can be picked, 80 can be picked. Okay, so out of these 9 elements we picked 6 elements, and these 6 elements are arranged in strictly increasing order, right? So the length of the longest increasing subsequence here is 6, and the sequence is this, right? So this is the problem which we solve, which is called the longest increasing subsequence problem. We will solve it using dynamic programming. Okay, so in order to apply dynamic programming approach on any problem, that problem should have optimal substructure. So now we will look at the optimal substructure of this problem. This problem is also having an optimal substructure. Okay, so let us say that you have an array list which is of n elements, and this array will contain your solution. Okay, and now if we consider a subsequence such as 3, 10, 2, 11. Okay, so the longest increasing subsequence here is 3, 10 and 11. So if we think about this subsequence, then this subsequence or any subsequence in general, it can start at any index and it can end at any index, and in between it can skip any number of elements, right? So these are the variations: starting variation, starting point variation, ending point variation, and there is a variation in how many number of elements are skipped in between. Okay, so we have to fix one of these things, and here in this solution to the problem we will fix the end point. Okay, so end point is fixed. So here we fix the end point here, lis I. Okay, so I can be 0, I can be 1, I can be 2, I can be 3. Okay, so I here means this is the longest increasing subsequence which is ending at index I. So here 0 means you are giving us the solution to the longest increasing subsequence which is ending at index 0. Similar, this is ending at index 1. The longest subsequence ending at index 2. The longest subsequence ending at index 3. Likewise. Okay. So this array is computed gradually, like as I drew here. So first we will compute LIS 0, then LIS 1 and so on. Okay, so after computing the solution to this array, the final answer will be the maximum value in your array. Okay, so whatever is the maximum value, that is your longest increasing subsequence. Okay, so how to find the solution? So let the current index be I. We want to compute the value LISI, and this means we are computing the longest increasing subsequence which is ending at index I. And for this, the previous values starting from LIS0 to LIS1 are already known. Okay, so here we see that there are a set of subproblems. You have subproblem LIS0, then LIS1, LIS2 and so on till LISI if you are talking about index I. And the last subproblem will be LISN minus 1, that is for the last index. Okay, so subproblems are there. Now you will see that there is optimal substructure also. So for each index I, you have two options. Like in every other dynamic problem, we have two or more number of options, right? So the first option is that, let me explain it with the help of the same example, 3, 10, 2, 11. Okay, so let us say that index is 0. First, this is your array and this is LIS which we want to compute. Okay, so first we will compute it for index 0. So at index 0, this is our base case. Okay, this is our base case. It means whatever element is at index 0, that is the part of the longest subsequence ending at that index. Okay, so this is trivial. Okay, so if we pick only 3 and our indexes are also starting at 0, ending at 0. Okay, so this is the only option. This is the longest increasing subsequence which is available to us at index 0. Okay, so it means the base case is already solved and the length of the longest increasing subsequence at the base case, that is at the index 0, is 1. Okay, so this is the option. Okay, this is the option. So I will talk about this after this. Okay, okay, so this is solved, this subproblem is solved. Now let us go to LIS 1. Okay, so this is the next subproblem. Now it means that you are finding the longest increasing subsequence which is ending at index 1, that is from 0, index 0 to index 1. Okay, so it means it is equal to maximum. Okay, so first let us look at this condition. Okay, so this index I, the element at index I will be added to the subsequence if this is greater than its previous element, right? So if the sequence happened to be like this is at 0, that this is at index 1. So would this one be a part of this increasing subsequence? No. We have to exclude this. Okay, if it is smaller than the previous element, the element can be included only if it is greater than the previous element. Okay, so this is the condition which is mentioned here. So it is saying that the element at index I, here I is 1, right, should be greater than the element at index J. Okay, so here J can be all the values which are smaller than I starting from 0. Okay, So j is greater than equal to 0 and less than I. Okay, so I is 1, so we have only one option for j. J can be 0. Okay, so this condition should be satisfied, and in this case this condition is satisfied, right? So your subsequence will be 1, because we are considering now, because our condition is satisfied, plus maximum out of the previous sub problems which you have already solved. Okay, so previously we have only this sub problem which is solved, and its value is 1. Okay, so 1 plus 1, your the subsequence which is monotonically increasing, the length of that subsequence is 2 at index 1. Okay, so this is done. Now let us move to next, that is LIS2. Okay, so LIS2 again, now I is 2, your j, now j can be 0 and j can be 1, right? Now you have two options for j, the previous problems which you have already solved, previous sub problems. Okay, so array at j should be less than array at I. Okay, so what is array at j when j is 0? This is 3, and array at 2 is 2. Okay, so this condition is not satisfied, right? Now when j is 1, then array at 1 should be less than array at 2. Is this condition satisfied? Array at index 1 is 10 and array at index 2 is 2. Again, this condition is not satisfied. Okay, so no such j exists. Then the only solution for us is to set it to 1. Okay, so it means that longest increasing subsequence at index 2 is 1. And which is that subsequence? That is 2 itself. Okay, this is the only subsequence which is monotonically increasing and which is ending at index 1. Okay, okay, so now let us move to the third index. Now I is 3. Now j can be 0, 1, 2. Now we have 3 options for j, and let us see whether this condition is satisfied. So array at 0 will be compared with array at I, that is 3. Then array at 1 will be compared with array at 3. And at last array at 2 will be compared with array at 3. Okay, so array at 0 is 3, array at 1 is 10, and array at 2 is 2. Okay, and array at 3 is 11. Everywhere it is 11. So now you see this condition is satisfied here. So it means we will consider LIS j. So we will consider the solution to LIS j. Here j is 3. So what is LIS j when j is 0? Sorry, it is 1. It is 1 here. Okay, so 1. And here also the condition is satisfied. 10 is smaller than 11. And what is the solution at index 1? It is 2. And here also the condition is satisfied. And what is the solution? Solution was 1. Okay, so we are looking at the previous subproblems, and out of these all subproblems we will pick the maximum. So the maximum here is 2. And now because 11 is greater than all of these, so we will include this into the list. So final solution for LIS I, that is 3, is equal to 1 plus 2. So answer here is 3. Okay. So now what is your final solution? What is the length of the longest increasing subsequence? For that, you will scan this array and find the maximum. Maximum is 3. So the answer is 3. Length of the monotonically increasing or the longest increasing subsequence is 3. And the sequence is 3, 10, 11. Right? This is the algorithm for dynamic. This is here we are using the dynamic programming approach. Okay, so how are we solving it using dynamic programming approach? This is the array which is given to you. Okay, and now I will explain it again with the help of some example. Let me take a different example this time. Okay, so now we have 5 values here. So n is 5 and this is your array, input array, and you can create another array of size n which will store your longest increasing subsequence. Okay, and for this, these are the indices 0, 1, 2, 3 and 4 for I equal to 0 to n minus 1, and this is the loop which is initializing every value to 0 initially. So initially everything is 0, and this is the base case LIS 0. At index 0 the length of the longest increasing subsequence is 1. Okay, then these are the two loops through which we will solve this problem dynamically. So I equal to 1 to n minus 1. So initially we are solving it for I equal to 1. That is the longest increasing subsequence ending at index 1. Okay, and j varies from 0 to I minus 1. So it is 0 only. It cannot go beyond 0 when I is 1. So I is 1. Okay, so this is the condition which should be satisfied. Array at j should be less than array at I. So array at j is 10 and this is 1. So this condition is not satisfied. So this will not execute. So we move to the next iteration. So j loop cannot iterate further. This j loop is complete. So now we will move to the next iteration of I. Now I is 2. When I is 2, j can vary from 0 to 1. Okay. So again we are comparing the values. Array at when j is 0, array at 0 should be less than array at I, that is 2. When j is 1, then array at 1 should be less than array at 2. Okay, so good. So array at 0 is 10 and array at 2 is 12. So you can see this is satisfied. So this statement will be executed. What is this statement saying? LIS I is 2 here, is equal to, so it will be maximum of LIS I, that is 2, comma LIS j is 0 plus 1. Okay, so LIS 2 is equal to maximum of LIS 2. What is LIS 2? we had initialized it to 0, so it is 0. And LISJ, what is LISJ? And that is LIS0. LIS0 is 1 plus 1. Okay, so this is 2. So out of 0 and 2, maximum is 2. So LIS2 becomes 2. So we have found a subsequence of length 2 which is ending at index 2, that is 10, 12. Okay. So now let us move to j equal to 1. Here array at 1 is 1 and array at 2 is 12. Again this condition is satisfied. So again LIS2 is equal to maximum of LISI, that is 2, comma LISJ, that is 1 plus 1. So LISJ is 0. What is LIS2 here? LIS2 we updated in the previous iteration, so LIS2 is 2. Okay, this is 2. And LISJ, that is LIS1 is 0. 0 plus 1 is 1. So we will not update it. Okay, so it will stay 2, right? Okay, sorry. So now we have to change it. Okay, it will it will not change, right? Because out of 2 and 1, maximum is 2. Okay, so we will keep the previous one, right? Okay, so now let us move to I equal to 3. When I is 3, j can vary from 0, 1 to 2. Okay, so we will also consider array at 2, and here we will compare it with array at 3 because I is 3. Here also it will be 3. Here also it will be 3. Right? And what is the value at 3? Value at 3 is 14. Here also it is 14. Here also it is 14. And 0 at 0 it is 10, then 1, then 12. Okay. So this condition is satisfied, this condition is satisfied, and this condition is also satisfied. All the conditions are satisfied. Okay. So here we will update LIS3. So it will be maximum of LIS3, comma LISJ plus 1. So initially it is LIS0 plus 1. Okay. LIS3 is 0. LIS0 is 1 plus 1. It is 2. So we will change. It will become 2. Then when j is 1, then LIS3 is 2 and LISJ, that is LIS1 is 0. 0 plus 1 is 1. So again we will not change it, right? Then we move to the next iteration. It is LIS2 now. So LIS3 is 2. LIS2 is also 2. Here we add 1. So it is 3. Out of 2 and 3, 3 is maximum. Okay. And J loop ends. After the end of the J loop, we find that LIS at 3 is 3. It means at location 3, at index 3, the longest increasing subsequence has length 3. And what is the sequence? It is 10, 12 and 14. Okay. And at last, we reach I equal to 4. Okay. So I is 4 now. And j varies from 0, 1 to 3. Right. So we will compare with array at 0, array at 1, array at 2 and array at 3. And it will be compared with array at 4. Right. I is 4 here. 4. Okay. So what is array at 4? It is 5. The value at index 4 in the array is 5. Everywhere it is 5. And first we will compare it with array at 0, which is 10. Then array at 1 is 1. Then array at 2 is 12. And array at 3 is 14. Okay. So here 10 is greater than 5. So this condition is not satisfied. If condition is not satisfied, so we will move to the next iteration of J loop. Here it is satisfied, so we will update the value at 5. Oh, sorry, not 5, index is 4. And J is 1 here. Okay. When it is 1, so the value here is 0. 0 plus 1 equal to 1. Okay. And LIS 0 is, LIS at 4 is 0. So out of these two, 1 is maximum, so we will change it. Okay. Okay. So next we reach here. Here we see that it is not satisfied. Here also we see that the condition is not satisfied. Okay. So with this entire thing, the two loops will terminate. And now let us see what is the answer. What is the length of the longest increasing subsequence? So for that we have to find the maximum value in this array. So we set the maximum value at index 0, and then from index 1 to n minus 1 we will compare this maximum value with the other values and change if we find any other value which is greater than this. Okay, so this is the normal code which you write to find the maximum value in an array. And here in this particular example you will see that the maximum value is 3. So the length of the longest increasing subsequence is 3, and the subsequence is 10, 12, 14. Okay, so this code only gives you the length of the longest increasing subsequence, but you can also actually find the sequence. Okay, for that you can create another array, suppose parent. Okay, so where you record the parent of, whenever the sequence is increased by 1, you record the ancestor of that sequence. Okay, so I leave this as an exercise for you, how to actually reconstruct the longest increasing subsequence. And the hint is using by recording the parent node or the ancestor parent index or the ancestor index whenever the sequence length increases by 1. Okay, so now finally let us look at the complexity of this algorithm. If you look at the time complexity, then this is a single for loop, but this is a nested for loop which is running n square number of times. So the complexity will be order of n square, the time complexity. And space complexity, here you are creating an array LIS whose size is n. Okay, so for this auxiliary space you will need you will have a space complexity of order of n. Okay, so this is all about this problem, longest increasing subsequence, which we have solved using the dynamic programming approach. Thank you.